I'm going to go over the information for your insulated cooler project. Yeah, just follow along, listen, and I hope you learn something and you figure out what you need to do for the project. So first, some learning goals. So the purpose of this is to learn how different types of insulation can slow down that transfer of energy in the form of heat. Okay. So you're going to investigate the engineering design process, which we've learned about this year. And so you're going to actually be doing that process again. You're going to design, build, and test your very own insulated cooler. Some vocab words that you need to know: insulation. So that's any type of material that slows this transfer of energy. So your winter coat is a type of insulation. Putting on socks is a type of insulation. So it's anything that's going to slow down the transfer of heat energy. Another word or vocab word that you maybe have heard of is called R value. So this is just the measure of how well the insulation slows the transfer of energy as heat. So the higher the R value, the more it slows the transfer of energy as heat. So if we were talking about winter coats and we, for some reason, decided to give them an R value, the warmer your winter coat, so the more it keeps you warm, it would have a much higher number R value. Where if you're wearing just like a really thin raincoat, it would have a really low R value number. So R value, if you ever go to a hardware store and you look in the insulation aisle, you'll see like R value 11, R value 17, things like that. And that's just telling you how well it's going to insulate whatever you put it on or put it around. So a little more information about insulation and heat transfer. So heat is that energy that's transferred between two objects when they have different temperatures. Heat energy always flows from the high temperature object to the low temperature object. So if I have a hot mug of coffee and I'm holding on to it, the heat is going to flow from that hot object, so the hot water. It's going to flow into the mug, which is going to be a lower temp, and then it's going to spread from that coffee mug into my hands, right? So it's flowing from the high temperature object to the low temperature object. Insulation slows down this heat transfer, okay? So a good insulator is actually a poor conductor of heat energy. So that means that heat energy doesn't travel through it quickly or easily, and so that's why it's called an insulator, right? It's slowing down the heat transfer. So materials with low density often make the best insulators. So think of density, what we've learned about it so far. Usually things that are low density float in water. So keep that in mind when you're picking out insulation materials for your insulated cooler project, right? So if you think about a metal spoons are going to get hot quickly if they're put in some sort of hot liquid versus like a plastic spoon or a wooden spoon. They don't get super hot right away because the lower density objects have more insulation, okay? So if we talk about different types of matter, so gases are better at insulating than liquids. Liquids are better at insulating than solids. And then low density solids are better than more dense solids at insulation. And so that goes along with that. If it's a lower density, it's a better insulator. So gases have a lower density, and so they are actually the best insulators, is using some type of gas as an insulation. So how insulation works. So its aim, remember, is to slow the transfer of heat energy between objects. You can probably hear my dogs barking, just ignore it. So insulation is supposed to slow down that energy transfer, right? The heat energy transfer. So for example, a double pane window will slow energy transfer by filling the space between the two window panes with a gas. I'm back. And I don't feel like redoing the whole thing I just said, so we're just going to make this a two-parter. Unless I get kicked out again, then it might be more than one part. But anyway, what I was saying is that common gases that are between those two panes of glass are argon and krypton, Okay, and so you can see a picture over here of what a window would look like if you were to like kind of cut through it. You would see your two panes of glass. A lot of times there's like a coating on it, and it helps reflect back sunlight. And then they actually fill that space with a gas. And then again, there's more coating and stuff, and they use low density materials to slow down the transfer of heat. There are such things as triple paned windows where there's actually three panes of window glass, and so that makes it so that it's insulated even more. So another insulation, think of insulated bottles or insulated coffee mugs. They often have a vacuum lining that prevents that energy transfer. And this helps because conduction, which is a type of a way to transfer heat energy, conduction can cannot occur in a vacuum where there's no matter or like no air. So if you look at this picture of a coffee cup, you can see how there's like an inner cup and an outer cup. And so that space in between there's either air, or if they're able to take all the air out, that's even better. So your hydro flasks, your insulated water bottles, your insulated coffee mugs, most of them are double layered like that so that it keeps the liquid either cold longer or keeps the liquid hot longer. Another example is that fiberglass insulation. It's used in lots of buildings. It's a great insulator. So fiberglass is a poor conductor. And it's a poor conductor because the loosely packed layers of spun glass trap a lot of air between them. So fiberglass, right, a fiber made of glass, fiberglass, is just really thin glass that looks like fibers, and they're kind of layered together. And so they trap air in those layers, kind of like a poofy coat that you would wear in the winter. And so that trapped air is a poor conductor of heat energy, because remember, gas is less dense, meaning it doesn't transfer heat energy very well. And so this is just a picture of what pink fiberglass insulation looks like. And so many houses have this insulation. There are other types of insulation that you can put in your homes. Spray foam is one of the best insulators you can have, but the trade-off is it's way more expensive than getting this pink fiberglass insulation. So remember, we talked about trade-offs, okay? So fiberglass insulation works, yeah, it's okay, and you get it for cheaper, so that's a good thing. Spray foam is amazing, a great insulator, but it's a lot more expensive, okay? So for your project, you are to build an insulated cooler. It can be small, it can be big, whatever. But what you must do is you must complete the science book pages. It's going to walk you through planning, okay? Give you some background information and walk you through the planning steps. Then you must build an insulated cooler. Just do the best you can. And you must test your cooler. If it epically fails, that is okay. That's how we learn. If it works amazing, that is okay, right? So whatever happens, it's okay. I just want you to try. And then really important that you must communicate your results. So these are going to be the science book pages. You have page 46, 47. Make sure you read everything on the pages, okay? Look at all the pictures, look at all the captions, read everything, answer the questions as you go. Then on page 48 and 49, this is where it literally walks you through the steps, right? Step 1, brainstorm. Step 2, pick a solution. Step 3, design a prototype. But I'm back. So what I just said was step 3, design a prototype. Then step 4, you build your prototype. Step 5 is your test. So it says at the beginning of a class period, find the mass of an ice cube, record your results below. For that part, whatever you can find that's cold that your parents will let you use in your insulated cooler, go for it and just write about it. Step B there, so test, evaluate, letter B. You're going to place the ice cube or whatever in your cooler, close it, end of class period, open the cooler, observe the ice cube, find the ice cube's mass, record results below. For that, just track how long you leave it in there, check it every now and then, and write down your observations. So is the ice melting, or maybe you put a popsicle in there. Did the popsicle melt? Whatever it is, write down information, write down your observations. And then that part C was part of the ice still frozen. Calculate the fraction of the ice cube that remained frozen. So whatever you put in there, you'll write like, yeah, it's still frozen, or no, it completely melted. And then just guess how much is still frozen. So if I think half of my ice cube melted, I'm going to say 50% is still frozen. If like hardly anything melted, I would say, 95% of my ice cube is still frozen. So just write down an estimate, a guess there for that. And then you need to fill out number 6, communicate results. So you're going to write it in your book, and then on Schoology, there's going to be a discussion post where you share your information there too. You have to communicate your results. Ideas for materials to use. So really whatever you can find laying around your house that your parents will let you use. So things like duct tape, if you have any boxes, or you could use plastic bags or a waterproof container, paper towels, cloths. If you have any foam packing materials or any sort of packing materials, newspaper, aluminum foil, if you have chunks of wood, if you have like straw, like hay, the hay kind of straw, right? Whatever you can find that your parents, grandparents, whoever lets you use, go for it. So how do I grade this? So there's going to be a folder in Schoology called Project Insulated Cooler. So you need to make sure you go through, complete all the work in that folder, and then make sure you share your results with us. The more you write about your experience and your learning, the better. Okay, so if you just type in like, oh, it worked, it was fun, that's not a good example of sharing your experience. So write down your steps, what worked, what didn't work. What materials did you use? How much did you use? Did anything epically fail? Did it work perfectly the first time? What would you do to make it better next time? Things like that. Okay? If you have questions, post them on Schoology, send me an email, Go Guardian chat, anything like that. Okay? So have fun. Good luck.